Continuous data is connected data. Yesterday we did discrete and that was disconnected. Today we're doing continuous and that's connected. So CCDD, right? So continuous is connected. Graphs of continuous functions can be drawn without lifting your pencil. And so continuous data means that the values between the points have meaning, which means that the partials are true. So remember yesterday we used like crumble cookie and how you can't get like 1.5 crumble cookies, and that's why it was discrete. Today we're looking at time versus distance. So even if on this time axis I had something like 1 minute, 2 minutes, 3 minutes, everything in between 1 and 2 minutes exists. I can have a minute and a half. I can have a minute and 45 seconds. I can have a minute and 55 seconds. So since everything between 1 and 2 minutes exists, that's going to be continuous data, okay? So we'll think about continuous data as anything that can be measured. With discrete, yesterday we said discrete can be counted. With continuous, we're going to think, can it be measured? So time, distance, anything that can be measured is going to be continuous. So our graph, again, if we were looking at time and distance, well, as time increases, maybe the distance increases, maybe it looks something like that, but everything in between, every single one of these points exists, which is why we can connect them. And I can trace this graph without picking up that pencil. So that's continuous because it's not just like distinct points. We got the difference between discrete and continuous. Okay, so the first characteristic that we're going to look at with continuous graphs is domain and range, just like we did with discrete, but it's going to be a little different this time. So the domain of continuous relations describes what is happening from left to right. And it's showing us which x values are used in that relation. So domain is still representing the x's, and we're going to be looking left to right because we want to be looking least to greatest, just like with discrete. The range of continuous relations describes what is happening from bottom to top. And it's showing us in that graph what are the y values that are being used. So, since continuous data is connected, today we're going to be writing our domain and range as an inequality from least to greatest. So remember yesterday with discrete, we got to list it. Today we will not be listing. We will be writing inequalities, okay? So I've given you even like an example over here. Something like your domain might be written like a compound inequality where x is between this minimum and maximum x value. And then our range, well, maybe the graph is just anything above 5. So that would just be a single inequality. Okay, we'll look more at that in a second, but this is how domain and range will be written when we have a continuous function, okay? Sometimes we're going to have continuous functions that don't have any limiting factors, meaning graphs are going to stretch all the way left and all the way right, or they'll stretch all the way down and all the way up. And if that happens, if there are no limiting factors, then the domain and or the range, either or, we would say is all real numbers. So if there are no limits, we don't need to write it as an inequality. We can just say all real numbers because there's no limits. All right, so let's look. We got our first graph here. We're going to state the domain and range, and then just like yesterday, you'll tell me yes or no, is it a function? So domain, we're looking at this x-axis. So we are going to look, what is the furthest left point on this circle graph, and what is the farthest right point? The furthest left point is going to be right here. The furthest right point is going to be right here. What is the x value of this furthest left point? -1, -2, -3. So the x value of this furthest left point is -3. And then the x value of this furthest right point is +3. So the x values in this circle are everything in between -3 and 3. So we're going to write that like a compound inequality, starting with the minimum to the maximum. So the domain would be -3. And then we're going to say that's going to be less than or equal to x. And then x is less than or equal to the 3. So we have that compound inequality where x is going to be in between the minimum and the maximum value. And we use the less than or equal to sign because this circle graph does have an x value of -3. That's included. And it does have an x value of +3. That's included, which is why we use less than or equal to. Okay? And just like in Unit 2 with the compound inequalities, how they always faced the same way, these are always going to face the same way. Okay? All right, now let's do range. So that's the y-axis. So now with the y values, we're looking bottom to top. So we've got the bottom of the circle down here, and we've got the top of the circle up here. What are the y values of that bottom and top point? So the y value of this bottom point is -2, and the y value of this top point is +4. So that means our y values are anything in between -2 and +4. So we'll write that like a compound inequality where we'll start with -2. It's going to be less than or equal to because it can be -2. This time in the middle, though, you need to make sure you put a y because we're talking about range, which is less than or equal to that top point, which is at 4. So these y values are in between -2 and 4. Is this circle graph a function? No, very good. It does not pass that vertical line test. Good job. Okay. Graph number 2. I call this like a Nike check. So the first thing we're going to do is domain. So domain is x's, so we're looking left and right. So the furthest left point on this graph is right here. And then the furthest right point is right here. So we've got this furthest left point. This is the farthest right point. What are the x values? If I'm using this x-axis as like a number line, the x value of this point is -1. And then the x value of this furthest left point is 1, 2, 3, 4, 5. So that means these x's will be anything in between -1 and 5. So we will write that as, starting with the minimum, -1 is less than or equal to x. What do you think about my next sign? Do you think the next sign is going to be less than or equal to? Why is it just going to be less than? Because the circle is open. Does everyone see how this point is open, which means it's not included, so we just have the less than sign. The signs will always be going this way. They'll always be less than signs, okay? It's just going to be, is it or equal to or just less than? All right? Okay, let's do the range. We're looking bottom to top. Is this the bottommost point of this Nike check? No, so please do not use this point. The bottom point, the bottommost point of this Nike check is right here. right? Because it dips down and then it goes back up. So this y value is -3, and then it goes up to right here, that highest point, which is at +3. So your range is from -3 to +3 and any values in between. So we're going to write that as an inequality starting with our minimum value, -3, is less than or equal to that y. And then once again, we're just going to put less than the +3 because this open circle is our highest point. And so since it's open, we're not including it. Is this Nike check a function? Yeah. Yes, it is. All right, graph number 3 is a little different because graphs 1 and 2 had start and stop points, both left and right and up or down. Graph number 3 doesn't have any points on it at all. Well, it has lots of points, but there's no like end points specifically. We've got these arrows, which means as I'm looking left and right, even though the graph runs off the grid right here because we don't want to make this humongous grid, this arrow is telling me it's going to keep stretching all the way to the left forever and ever and ever. And this arrow is telling me it's going to keep stretching all the way to the right forever and ever. So when I'm looking left and right, there are no endpoints. This arrow, it's going to keep stretching this way. This arrow, it's going to keep stretching to the right. So this domain is an example of something that has no limits. It's going to keep going left. It's going to keep going right. Therefore, the domain of this U-shaped graph is going to be what? All real numbers. Very good. So this domain is all real numbers. Okay, now bottom to top, a little differently because if I look for a bottom point, do I see a lowest point on this graph? Yeah, it's right here at -2. But as I search for a highest point, do I ever see one? No, because it's going to keep going up, 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 up as it's going left and right. So what that means is these y values in this function are just going to be anything above or anything bigger than -2. So instead of being a compound inequality, this is just a single inequality where y is going to be greater than or equal to -2. Because the y values aren't in between a start and a stopping point. They have a stopping point, but then they go on forever, right? Or a starting point and they go on forever, whatever. So y is greater than or equal to -2. And I already said this was a function, so let's go ahead and just put yes. That passes that vertical line test. All right, number 4, the last one that's going to require, a little more thinking, and then I promise this last thing we're going to do is really easy, so it'll be fast. All right, number 4. A ball was dropped from a balcony at a height of 20 feet above level ground. So can you guys picture it? You're standing on a balcony. You drop a ball. Got it? That's you. That balcony is 20 feet high. So you're on a balcony that's 20 feet above the ground, and you drop a ball. The height in feet of the ball after t seconds is modeled by the function y equals -16t squared plus 20. The question is, what is the range of this function in terms of the situation being described? So the range is which variable? The range is which variable? Y. So this is my range, these possible y values. So this is a multiple choice question, which means we can go ahead really and just use some process of elimination And we can already cancel out which ones aren't going to be the range, because range is y, which means which ones can we already cancel out? A and C. It's not A, it's not C, because those are talking about time. And the time is representing seconds. And what we are looking at is this y value, which is representing height. So now all we have to decide is what are the possible values for the height, because that's what the y represents. What are the possible values for the height? I'm going to turn B around because we all know that I don't like this. So I'm going to rewrite this as y is greater than or equal to 0. Okay, so now are the possible values for the height y anything greater than 0? Remember, you're on a balcony 20 feet above the ground and you drop the ball. Or are the possible values for the height between 0 and 20?
D.
Can the height be 21 feet? 22 feet? 23 feet? No, it's only 0 to 20. So that would be the range. Good job. I pulled that question from last year's EOC, so. Okay. Real quick here, we're going to talk about end behavior. End behavior is a characteristic that continuous functions have that discrete didn't, which is why we didn't talk about it yesterday. End behavior of a function is the behavior of the graph as x approaches positive infinity or negative infinity. So what this means, right here, as x approaches negative infinity, so the x-axis is our horizontal axis, so negative infinity would be over this way, right? As x approaches negative infinity is asking about which direction the left ending arrow's range is going towards. So in these continuous functions, they have two arrows, one on the left and one on the right. And all you have to do when you describe the end behavior is tell me the left arrow as x is going towards negative infinity. Look at the arrow on the left side. Which way is that arrow moving? Up or down?
Down.
Down. So that means these range values, as x is going towards negative infinity, these range values are also going towards negative infinity. And that's the end behavior. Okay? Then, as x approaches positive infinity, so x towards positive infinity, that's the right side of the graph. So that's asking which direction the right ending arrow is going towards. So if I look at this example, as my x's are moving towards positive infinity, this right arrow is moving up, which means the range values are also approaching positive infinity. So if the arrow is going up, it's positive infinity. If the arrow is going down, then the y's are moving towards negative infinity. Okay? Here we go. Real quick. Number 5. As x is moving towards negative infinity, what are the y's are doing? So negative infinity is the left side. So look at the arrow on the left side of this line. Which way is this arrow moving? Up, which means y is approaching positive infinity. Then, as x is approaching positive infinity, so now we're looking at the right side of the graph. What is this right arrow? Which direction is it moving? Down. So y is going towards negative infinity. All right. Number 6. As x goes towards negative infinity. So I'm looking at the left arrow. Which way is the left arrow moving? Down. So y is going towards negative infinity. As x goes towards positive infinity, so positive infinity is the right arrow. Which way is the right arrow going? Also down. So that's also negative infinity. Because they're both ending pointing down. Last one, number 7. As x approaches negative infinity, So negative infinity is the left arrow. Which direction is that left arrow going? Up. So that means that y is going towards positive infinity. And as x approaches positive infinity, well, that means the right side of the graph. And what's the right arrow doing? Going up, which means y is going towards positive infinity. And behavior is easy, right? That's just arrows. Domain and range, a little more challenging, but you're just looking for minimum and maximums and writing compound inequalities. And if there is no limits, it's all real numbers. Okay? All right, so like I said, you got 20 minutes. You got 10 problems.
Oh, you got it.